So welcome to the second part of the lab, OSPF configurations. As I said, this lab will basically show us what we need to do when we are using OSPF dynamic routing protocols. So as the good thing of OSPF is dynamic routing protocol. That means it can sense the topology change. Let's take an example. You see, the PC1 is connected to the OSPF domain via Paris router. So when I need to access, because my target is to access internet, so from the Paris router to the internet, it could be either via Moscow, London, or Dodoma. So either of these three paths, it can take me to internet. But one of the links should be used at a time, or two of the links, or all of them should be used at the time, depends to the cost of the link to the destination. You see here, because here we have Giga Ethernet and here we have Fast Ethernet interface. So when I need to access internet, basically the PC1 will take a path from Paris router to Moscow router all the way to Tokyo router, because the speed of this interface or the speed of this link or this route is much higher and a short compared to this distance or cost from Paris, Dodoma, Nairobi, Tokyo. So the best route will be just from Paris, Moscow, Tokyo, and so on. So from now, let's proceed. Let's go forwards and see the details of the lab. That means we need to see the networks and the networks plan, the point-to-point plan, IP, and some cool stuff based on this lab. So I'm gonna pause the videos and I'll go and put the network IP plan and or other stuffs on this. Then I'll resume after doing completing that task. Okay, so now you see all of the interfaces, they have been assigned IP addresses. As you can see here in details, you see here that we have a network 192, 60, 50, and 0/24. So this is a network. This is our network. Now you see this is our point-to-point network. Point-to-point network 50. You see this is sorry. I mean this is not correct, because it's supposed to be point-to-point. It's supposed to be point-to-point, which is 30. If you understand the subnetting here, you understand. I mean they should be 30, because it's a point-to-point network between one router and the second router. So it's not supposed to be /24. Okay, let me correct all of them and we'll proceed. Okay, so 30. Okay, one more. Yeah, now it's okay, all right? So you see, between Paris and Moscow, we need to have a point-to-point so that we achieve the IP networking between these routers. So you see, we have 192.160.50.12 is a network. So and the network just have 4 IP addresses. 2 is usable, 1 is network, and the other is broadcast. So if it's 12 is network, 13 and 14 will be usable, 15 will be broadcast broadcast IP. So the next block will be another network. As you can see here, we have 102, 160, 50, and 16. 16 is another network. So 17 and 18 will be usable, and 19 will be the broadcast IP. So the next block will be the same, will be network. So see 192, 160, 50, 20 it's a network. So 21 and 22 are usable. So this is how we're going to connect. We're going to connect this simple topology here with a point-to-point IP. Moreover, I've already designed the networks IP of each region. Here you see on the Dodoma network, a network that is connected to the Dodoma routers will be known as 172.16.100.0/24. I mean, here we have usable around the 254 IP addresses. The same applies to PC1, which is connected to Paris. The network will be 10.10.10/24. And the FTP server will be located at this IP addresses. So whenever I'm trying to reach FTP server, the FTP server will be reachable via these IP addresses, which is 172.31.0.100/24. The same applies to internet. I've selected 8.8.8.8 as a Google. So this is just a good example of how to elaborate if someone needs to access internet. So this IP will be the one of the it will be a representative of the internet. So whenever I'm trying to ping 1.8.8.8, that means I'm pinging the internet. So the next step is to assign IP address to the nodes based on the Huawei's syntax. So because this is Huawei's Huawei lab and is simulated in the Huawei environments, so everything that is going to happen here is based on the Huawei's standards. So on the IP address assignments first, I'll go to the to the PCs. As you can see here, let's see, try to put this IP address on the PC1. So double click the PC, then go to commands, basic configurations. Then here we just name this as PC1 as it's known, and the IP address will be just 10. It will be 10. Sorry, it will be 10 dot dot 2, and the subnetting mask is 24 /24 or 255.255.255.0. The gateway, it would be dot 1, which is the interface at Paris router. So it will be 10.10.10.1. Then I go straight to apply so that the configuration will not be lost at the next boot up. That's be the example on the PC. So you do the same way to PC2 and the other all nodes that is having the same interface as PC. But for the FTP server, let's go and see how to put IP address on the FTP server. So you see here we have IP configs and we have a ping test. So on the IP configs, we just put the IP address of the server, which 172, we have 31, we have 0 and 100. This is IP address of the of the FTP server. But the gateway, it's 172.31, goes straight to .1, which is the interface of the Nairobi router here. So after that, go straight to save, so that to make sure all the configuration are stored. But also we need to set this server to FTP. So go to server informations, straightforward to FTP. Then on the FTP, we can just select one of the directory that will be our, it will be, you see here, when it's trying to start FTP, the FTP will request you for the root path. So you need to select the root path of the files that will be stored when the FTP server is running. And so because for the FTP server, so I'm going to select any directories, any path in my computer, and keep that as my FTP directory. So you see here, I have FTP directories in one of the my useful document here. So I've copied this path and I'm going to put it here. So to put it here, so it needs me to select. So I'll go direct to lab, then after lab, Okay, directory. Where is projects? So after selecting the path, you see here, now on the selected path or selected directories, there is a test files. So after selecting that path, then you start the server. So the server will be started. So you see here, now on the logs, it says that the FTP server information, it is listening. So now the server is in the listening mode. So what next is to to configure IP addresses on the routers. So let's try to configure IP addresses and all other stuffs on one routers, and I'll show you the quick way of assigning IP address to the other interfaces. So you see, let's go direct to this interface, to this router, which is called the Dodoma. So this on part of that, let me add one more point. Like what I'm adding one more point, because we're going to configure OSPF. And the OSPF needs the router that are participating in the OSPF should be in the same area, so that for the LSAs, or the linked advertisement packets, to be propagated to all other routers for the routing calculations and so on. So the OSPF, basically they are selecting the router ID of the router. So any router that is participating to the OSPF, it should have a unique ID, a unique identifier that will be identifying that router uniquely to the OSPF domain. So if you will not configure manually the route ID, the route ID will be selected by the OSPF process automatically. So it will take the one of the biggest IP in the the router. If you have configured the loopbacks, if you didn't, it will just select the IP address or the physical IP address, which is highest compared to the others. So for me, because I don't want any confusions, so I'll go dialects and assign the IP addresses, the route IDs to all of my OSPF learning routers. So I'm going to pause these videos, and I'll plan and design the route IDs for all of six routers. So let's pause, and let's meet again after some time. So after assigning the router ID, you see here we have 1111 for the Dodoma router, we have 555 for Nairobi, 444 Tokyo, 333 Moscow, Paris 222, and London is 6066. This is the router ID. It's uniquely identify the router in the OSPF domains. So whenever the packets are sent from one router to another, so the packets will be binded, will be tagged together with the router ID, which is identifying that router uniquely in the networks. So let's go forward and assign these details to the router. So open the power on the devices, and after that, open the console of the, okay, now my device is booting up. Devices are booting up. Okay, let's wait for some time until they come up. Okay, now the router is on completely and successfully. So let's go forwards and assign these useful informations on the router. The first thing that will be assigning EO will be configure the system name, the router name. So we'll name the router as its name. So another thing will be configured is router ID for the router, also the IP addresses of the interface, the descriptions, and there's some more cool stuffs that we're going to see in this beautiful lab. So after that, let's go direct to the IP address assignment. So let's enter to the router, which is the first router called Dodoma. So in this router, so if you need to configure anything, you have to enter to the system view, then assign the system name to Dodoma. You can say Dodoma. So that's the system name. After that, let's put router ID. Router ID. That's one way of assigning route ID on the router. So there is a one way, which is to assign route ID in a specific protocol. As we will see that way of assigning the the route ID on the specific protocol. But another way is to assign IP address globally. That means if you didn't assign the route ID on a specific protocol, the protocol will go direct to the system and pick the route ID of the system. But if you assign the route ID on the protocol, there is a local significance, because the route ID that is configured on the protocol view, it's more preferred compared to the route ID which is configured to the global view. So the route ID of this one, it's 111. Now, okay, I think it has to be it needs to have with space. So the command is router ID, then you put the IPv4 address as its router ID. After that, we are going straight to assign IP addresses on the interface. So starting with interface which is facing to the network, to the switch one. So it's interface giga 000. So on the interface is 000, the IP address is 172.16.100.1.24. The IP address will be 172.116.100.124. And the description is a link to switch. Why I put descriptions is to give me more details of where the port is connected. You see, the Giga 000 is connected to a switch here. So when I log into the router, the Dodoma, then when I display the description of the interface, you will just be simply seeing where the interface are connected without maybe getting some more information. So it's just give you the more definitions of something in the router. So this one is connected to switch one. So let's go the same to this interface, which is 000 connected to Paris, and this one linked to Nairobi. So after that one, you can display this to see what is configured on that view. Now you see the interface is 000 is connected to it's a link to switch, and the IP address is this one. So let's go direct and assign IP address to the interface, which is Ethernet 4.00. So Ethernet 4.0.0 is the one which is connected to Paris. So the link description, it is link to Paris. Put the description needs. And IP address, it should be this point-to-point IP address, which was 192.160.50, and the network is 24. So this one is 26, it will be 30 because it's a point-to-point network. So when you display this, you will see then moreover, let's assign another interface which is connected to Nairobi. So this description is link to Nairobi. Okay, and then IP address. Let's put the IP address of that, which is 21. The IP address, it should be 192.160.50.21.30. So now done. You see now the IP addresses and the descriptions have been configured. How to verify? You just go to the system view and then display IP interface descriptions. The IP interface descriptions, it will give you the IP interface with where they have been configured on the interface and the descriptions of where that link or port is going. So see here, the Ethernet 400 is going to Paris, and the IP address of it is 26. You see, 26, and the status of it is up, protocol and the physical app. But we have others interface which they have unassigned, as they don't have any configurations on them. That's one. And I'll go straight to save. That will be the first part of this lab. So now we see we have done a simply the configurations on the Dodoma routers. We have put the router ID, the system name, the IP address, the descriptions, and some cool stuff. So let's see how we can also assign IP addresses on this. I can just pause this video and going direct assign it to the nodes. But for me now, I'll just show you how you can assign it easily. So let me open my notepad. Let me open my notepad. Open the new page. After this page, let's see how we can assign IP address using script. So the first thing is to create a script which is common to all routers. Whenever we are running this script, it will change everything that is directed to be configured on the script. So my first line is hash. Hash means return. It has the same meaning with the the command quit. Example, when maybe I'm in the interface giga, let's say 000. So when I put hash here, you see it will just go one step back. It has the tendency of one step back, but I don't think it's reflected. But in the real equipment, it has that meaning. If you put hash, it has to go back one step to the system view. So that's why we are using hash here. So when you put hash, that means you are telling the router to stay to the system view or to return one more view to the system from where it is. So the first command will be the system view. It will direct it will basically tell the routers to enter to the system view. After the system view, I'll go direct and assign router ID of the router. So for me here, I'll take Paris as an example. So the router ID of the Paris is 2222. So go direct to configurations. Okay, go direct to the configuration, which is 2222. That's the router ID. Then you put hash. After the hash, put the system name, which is Paris. After that, go direct to the IP addresses assignment of the interface. So we have 4 interfaces, which is 0, 1, Ethernet is 04, and Ethernet is 0. The Ethernet is 01. So the first interface, it's interface. Sorry, let me use. Oh, sorry, I'm too fast. Ethernet giga 000 and 000. It's the link to Moscow router, and it has IP address of the 13. So on the description side, it's descriptions. It's a link. I can say link to Moscow, and the IP address of which is 172.168.15.13.30. See, now we have another interface. Let me copy this one because it's very easier to use. Okay, we have another interface which is 001. Okay, this one which is 001. This is linked to London. IP address, it's the same. It's this one, but the network is different. It is 5 instead of 13. We have another interface connecting to Dodoma, which is 4. Let's go direct, but here it's not giga. The interface type is Ethernet 400. The link will be to Dodoma, my capital city in Tanzania. So IP address is 24. Okay, let's go direct to 24. And the last interface is connection to a PC1. So here I can say link it to PC1, and the IP addresses is 10.10.10.1. So let me change direct this one to 10.10.10.1, and then the subnet mask is not 30, it's 24. So you see now this beautiful script here. So this script, what we just tell was just do, it will just I mean, okay, one more point here. First I have to return to the user view. Then after user view, I'll save the configurations. So the script will just do what we just do. It will just enter to the system view, put the system, I mean the route ID, assign the system name, and then put the description, the IP addresses on the interface as shown here, dialect. So this one is not Giga Ethernet, it is Ethernet, I mean for one. Okay, now let's auto test. Just copy the configurations, go directly to the router that is as an example. Okay, this one. Then after that one, what you need to do is to paste the script. Now you see pop, the script has been learned and the configuration entered. So how to verify? You just put a very beautiful command, which is IP display IP interface descriptions. So this one, it will give you the description of the interfaces and where they've been connected, where they've been connected. So we have Giga 00, we have Giga 01, and we have one with interface which Ethernet is 00. Okay, why this one we don't have IP addresses? Why? Let's go back to the script. Okay, it's here. It says no. You see, the network is 24, but the first IP is 25. That's why it was denied. So it was denied to assign that IP address. So that's cool. Let's copy again the configurations, go to the Paris router, paste. Now, boom, now we have IP interface descriptions. Oh, now, wow, you see now the IP address is assigned and it's a link to the DOMA. So now how you can assign IP address to the interfaces. That's a beautiful way. So let's go and do the same to all other routers that left in this lab. So for me, I'll just do one more, two more, then I'll put the videos and I'll finish up all others. For you, you can just use the way that I showed you shortly, or you can use your own way that you see it's comfortable for you. So let's try also for Moscow. For Moscow, we have 3 interfaces and the route ID is 1. So let's go direct, copy this script, open the new page, paste. Let's change only attributes that is variable. And here the route ID is 333, the system name is Moscow, but 0 is connected to Paris, 1 is connected to Tokyo. So this one is connected to Paris. And 1 is connected to Tokyo router, but we don't have, and the 2 is connected to PC2. So we don't have Ethernet, we have Giga 002. And we don't have this interface, delete it, and this is connected to PC2. Yes, PC2. The IP address of this one, it will be 17.172.16.0.1. It will be just 16.0.1, and the subnet mask it's possibly being 24. The network to Paris, it's 12, but here it's 14. Now, yeah, you see now it's 14. To Tokyo, it's 0, but here it's 1. See, here it's 1. Now, boom, copy your script, go direct to the router, which is Moscow, paste the script. You see now the configuration has been reflected, display IP interface description. Now, boom, you see the configurations they've been reflected to the system. You see the IP addresses are here, subnet mask is here, the port is up, and the description of the interface is already there. And the script we are saving also the configuration at the end. So let's do one more Tokyo. One more Tokyo, open the script, copy the same command, then paste here for the Tokyo. We have three interface also. This one connected to the internet. Giga00 is connected to Giga00 is connected to Moscow. 002 is connected to Nairobi. So the script is 00 is connected to Moscow. 001 is connected to internet. 001 is connected to internet. That's the description. And here is connected to Nairobi. So the network, okay, go use this one. So the network is 0 to Moscow, 17 to Nairobi. So 17 to Nairobi, which is basically 192, 160, 50, 17/30 for the point to point. And Moscow is 2 for the point to point, but for the internet, let's put this one. For the internet, it's put 111.124. It's a gateway for the internet. You see, the internet IP is 8888 for the internet, but for the gateway, for it to access, it will be just 111. So any feedback, any reply from the internet, it will be forwarded direct to the next hop, which is 8881. Also for us, when we need to access the internet, we should be able to reach 888 by any means in the network. So this is a second script, which is going to to Tokyo, but here the system ID is 444, the route ID is 444, and is Tokyo. You see, okay, go straight. And one more, let's add more command for display IP interface descriptions. So this script also will give us the description of the interface. Go direct to Tokyo router, assign at last. The script also give me the IP addresses and the descriptions of the interface. Now you see how it's very beautiful and very easy to assign IP addresses using that a short script. So I'm gonna pause these videos and try all other, assign all other left part. Okay. Okay, now I've already assigned all IP addresses, as you can see here on the screen for the randoms. These are the configurations, and they're reflecting the same as what is on the topology. For the Nairobi also already completed. There is a link to the FTP server, and the gateway is 172.31.0.1.24. This is the network, and we have this point-to-point IPs for the interconnections between routers. You see, there is Ethernet, fast Ethernet interface here, and there is a Giga Ethernet interface here. To see what that means, you can display interface. Now start with Giga 000. You can see the interface descriptions of that. It says the speed is 1000 megabit per second. So that's the speed of the interface. But when you go direct and put, the Ethernet 4, you will see the speed, it's the same, which is fast Ethernet. It is, speed is, okay. That's cool, but also I'll try to modulate. So I try to, to change this speeds to to 100. You can see, just go direct and the interface, into the interface view of that router. Okay, it needs to assign. It's 400. So after here, speed. Can you put 100? Please undo negotiation first. Undo negotiation auto. Configuration fails. Okay, it fails to assign the to change the speed of this port, because I just wanted to show you how the OSPF is calculated with different speed interface. But for this ones, unfortunately, it is Ethernet interface, but the speed of it is 1,000. For the 1,000, it's kind of cool. It's high speedy. There is more information here we can extract. No, I just want to see the capacity of the ports and there's some stuff as you can see here. I think we don't have more any information on this one. The speed is 1 and the fault is copper. Okay, cool. That's how we can assign IP address. So from this part, we have seen how to assign IP addresses on the OSPF lab. So let's proceed and familiarize ourselves what we should do next. But for the next part, it's where we're going to start the OSPF configurations. I'll show you how to design and configure the OSPF configuration the same and the simplest way as what we did here. It'd be cool and it'd just be cool. I'll show you how. Okay, let's meet again to the next